So hello everyone. In our previous lectures, we had finished the physics part of general science. In this lecture, we will start the chemistry part of our general science. Okay? So let's start. So basically, chemistry. What do you mean by chemistry is the first question. Or you can say chemistry is a study of chemicals. Chemistry is a study of chemicals. Okay? And what do you mean by chemicals? Chemicals are basically substances which are used for creating or destroying things. Which are used for creating or destroying things. Okay? We will have a discussion over creation or destroying in our upcoming lectures. Till then, just remember that chemistry is a study of chemicals. Got it? So here, one thing which we need to make sure before we start into the depth of this chapter is that we must know about the atom. Because in chemistry, everything revolves around the atom and everything is directly or indirectly connected with the atom. Got it? So first question is, what do you mean by atom? What is a atom? Okay? So if you see anything around yourself, like it's your television, it's your pen, it's your mobile phone, it's your food, it's your, you can say, the air which you are breathing, it's a water you are drinking, and anything which you notice around yourself or which you can see around yourself is different in chemical or physical aspects. In chemical and physical aspects. All the things you are seeing around yourself are different to each other in their physical and chemical aspects. Okay? For example, like your television, you can see your television, but can you see the air surrounding yourself? You can see your drinkable water. Okay? And if you pour water in the bowl, then your water will be in that shape. When you pour it into glass, then it will be in that shape. But if you pour your pen into the bowl, then will your pen change your shape? But if you pour your pen into the glass, then again, can your pen change the shape? No, right? So means they are physically different. Okay? And their chemical configuration or your chemical build-up is also different. And how is this possible? How is this possible that everything is different but one thing is common, which I'm going to tell you. Everything is different but one thing is common. And what is the one thing which common in them is atom. Okay? Everything you are seeing around yourself, whether it is in a solid form, whether it is in a liquid form, whether it is in a gaseous form, everything you see around yourself having one thing common, this is the atom. This is the atom. Okay? If atom is common in all of them, it is common in solid, it is common in liquid, it is common in gases, then how these things are different in their physical and chemical aspects. Okay? So we will discuss this in our upcoming lectures. Till then, just remember that atom is basic thing in every form, like whether it's solid, liquid or gaseous. Got it? So here we have come to know about that atom is very important thing. So first thing is that what do we call atom? Like what is the meaning of that atom? How does it looks like? How does it looks like? What does it shape? What does it size? Okay, so these type of questions should come to our mind. Okay, so let's start answer this thing. First of all, Democritus, he was a Greek philosopher. Democritus was the one who first time mentioned about atom as atomos. Okay, and these atomos are basically considered as building blocks. Because everything you are seeing around yourself, like the solid, liquid, and gaseous, all the things are made up of atoms. So that's why they are called the building blocks. Got it? But we need to know more about the atom. Okay? So in this scenario, one person came into the picture whose name was John Dalton, and he proposed the theory, Dalton's theory of atom. Dalton's theory of atom was given by John Dalton. In this theory, he made 4 points. First point was, let me write down here so that you can understand better. A, B, C, D. 4 points. First is atoms are invisible, minute, and indivisible particles. It was the first concept. Second, similar in shape and size for same element. Okay. Thereafter, third point was different shape and size for different element. Okay, and the fourth point was cannot be created, destroyed, and transformed. So these were the 4 points made under the. These all 4 points were made under the Dalton's theory of atom. Made under the Dalton's theory of atom. That he said atoms are invisible. They are so minute that you cannot see them by your eyes. Okay. Second thing he said atoms are undivisible. Means they cannot be divided into further units. Can't divide it into further units. So you can say atoms is the final unit. Got it? Thereafter, he said atoms of a single element are same in shape and size. What do you mean by element? Now the question is, what do you mean by element? What do you mean by element? And similar question for element is, what do you mean by compound? So there are two concepts basically which we need to understand here. So first is the meaning of element. Substance made up of one, or you can say single type of atom. Okay, element is a substance which is made of one or single type of atom. Okay, and compound basically group of elements. Okay, so here you can say if this is one element and then 1, 2 and 3, these all three elements get combined together. So in that scenario, this is the element, but they all are forming compound. Okay, so we say in one compound, in one element, atoms are same in shape and size, whereas for different elements like 1, 2 and 3, atoms may be different in shape and size. Okay, and third and the fourth point, he said that atoms cannot be created, they cannot be destroyed, and they cannot be transferred from one to another. Okay, so these were the points of the Dalton's theory. Okay, and these theory got failed. This theory was get failed, and the question is on which grounds this theory was failed. So let's understand the grounds on which this theory was getting failed. Okay, so first question is indivisibility. Indivisibility. Like Dalton said that atom cannot be divided further, but in today's terms or in the modern atomic theory, atoms were further divided into proton, electron, thereafter the neutrons. Okay, so first his indivisibility was challenged and also get failed because proton, electrons and neutrons are the further division of atom. Okay, and second was unable to explain atomic structure. Unable to explain atomic structure, like the word you can see here. So these were the failures for the Dalton's theory. Okay, so here we have come to know about three more words like the proton, electron and neutron. We know that these are the parts of the atoms, but we should know some things about them. First is a proton. Basically, protons are the positively charged particles. Okay, it was discovered by Goldstein, but was named by Rutherford. Okay, so basically the proton is a positively charged particle which was discovered by Goldstein but was named by Rutherford. Okay, then after this the second is a electron, which is a negatively charged particles which were discovered by J.J. Thomson and was named by Stanley. Got it? Thereafter, the third and the final one. It is neutron, which is a neutral or zero charge particle. It means neutron has no charge. Was discovered by James Chadwick and was also named by James Chadwick. Got it? So protons are basically the positively charged particles discovered by Goldstein, named after Rutherford, whereas neutrons are the neutral or zero charge particles discovered by James Chadwick, named by James Chadwick. Okay, whereas electron are the negatively charged particles discovered by J.J. Thomson and named by Stanley. Got it? Now, let's move forward. Okay. So basically here we have come to know about the first introduction of the atom by Democritus, then the explanation of atomic theory by John Dalton, and thereafter we also come to know about several parts of the electrons, protons and neutrons, which are the part of the atom. Okay, but here is one question: how do we find them? Okay, how they discovered? So basically, after getting the information of the atom, we all are trying to get the atomic structure, like how does the atom looks like. That was our main priority. Okay, for this there are several atomic models, but there are three important atomic models for the examination point of view. So the first is Thomson model, also known as plum pudding model, or watermelon model. And why it is called as a watermelon or plum pudding? Let me explain you. Basically, he said that atom is in a spherical shape. Atom is in a spherical shape, and thereafter it has some dots inside it, and these dots are basically the electrons, or you can say the negative charge particles. Negative charge particles. Okay, and these particles are suspended within a positive plane. Positive plane. So this was the explanation for Thomson model. Like he said, these dots are basically the negative charge particles, and the gap which you can see here is basically the positive plane. Okay, so this was his theory. And now let's connect it with the watermelon. So if you see the watermelon, then watermelon is a spherical shape, and in the watermelon there are some seeds which appears like a dot. Okay, and in watermelon there is a open space in red color, right, which is also the eatable part. Got it? So basically, if you started comparing the watermelon, so if you started comparing the watermelon with the, so if you started comparing the watermelon to this atomic structure, okay, so here you can see the suspended particles or the seeds are equivalent, and the open area with the positive plane and this red color part of the watermelon are the same. Okay, so that's why it is called as the plum pudding model. Got it? And after him, after Thomson model was basically got failed because he was unable to explain that how the negative charge particles are suspended in the positive plane. Okay, so he was unable to explain it. Thereafter, the next man was Rutherford. His model is known as scattering scale model. Just scattering model. Okay, basically he used gold foil basically, and then he used alpha particles beam to flash on this gold point, and after this he made some statements. He said basically there is a center of an atom and all the electrons are revolving around it. It is a center of an atom basically you can say center of atom, or it is also known as nucleus. Okay, and these particles which we called electrons are revolving around it. Okay, so there are two main questions on Rutherford. First is collapsion Second is force of revolving. Okay, so the first question arrived that if the electrons are revolving around the center of an atom, okay, so after some time electrons should lose energy and collapse with the nucleus, or you can say with the center. Okay, so the first question is that, like, if something is continuously revolving around something, then after some time the revolving body will lose the energy and will get into collapse with the center. Okay, but generally in atoms it does not happen. So the first question is that what is the force behind it, and second was the force of revolving, like why the electrons are revolving around the nucleus. Okay, what is the reason? So these two questions arrived on the Rutherford's model, and ultimately Rutherford's model was failed. Got it? So that's how Thomson model and Rutherford model get failed. Now let's talk about the third most important model. Third most important model, which was the Niels Bohr's model. It is also known as concept of quantization of energy. Concept of quantization of energy. Okay. So after failure of the Rutherford model, Thomson model says, like here in this picture you can see, basically he said that no doubt there is a nucleus in the center. There is a nucleus in the center. Okay, and electrons, the outer diads, are revolving around it. Okay, so he explained two things. First, collapsion. He said because they are revolving in a definite path or shells, like these lines. So these lines are basically the shells. So he said because the electrons are revolving in the shell, then it is not possible for them to get collapse with the center. So that's how he answered the first question, the question of collapsion. And second, he said basically the nucleus comprise proton and neutron. Proton is positive, whereas neutron is zero, or you can say neutral. Okay, so because nucleus comprise of these, so nucleus generated an influence over the electrons, so that's why the electrons are revolving around it. Okay, so that's how Niels Bohr answered the questions. Got it? So now we have come to know about the different atomic structure, starting with the Thomson model and why the Thomson model get failed, then Rutherford model, why it was failed, and then Niels Bohr model, why it get succeed. Okay, now let's move forward. Here you can see at the center of an atom there is a teeny super important part. As I have told you, it's a nucleus. It is the heart of the atom because it is lies at the central part. So that's why it is known as the heart of the atom. Okay, and it's comprised of the two things. Basically, nucleus comprised of the two things. The first is proton, positive charged particles, and second one is neutron, neutral charged particles. Yeah, you can say neutral particles only. Okay, so now let's move forward. Around the nucleus, there are even tiny superparticles called the electrons. And we know electrons are basically negative charged particles. and they are revolving the center. Like it is a center, then they are revolving around us. And why they are not collapsing with it? Because it is revolving in a proper, definite way. Proper, definite way. Like this. Okay? If this is a nucleus and this is the electron, so it is basically revolving in a particular orbit, or you can say particular shell. Got it? So now let's move forward. Basically, here is a concept of atomic number and atomic mass. Okay, so to better understand the different phenomena relating with the atoms, we must understand what do you mean by atomic number and what do you mean by atomic mass. Okay, so basically atomic number is number of protons inside nucleus. Okay, so basically the atomic number stands for the number of protons lies inside the nucleus. Got it? The second term is mass number, which is also known as atomic mass. Okay, so atomic mass basically stands for total mass of an atom. Basically stands for the total mass of an atom. Okay, or you can say including both proton and neutron of nucleus. Got it? So it is about the atomic number and the mass number. And why they are important? Why we are studying them is the main question. Because in our upcoming lecture, we will have a discussion over periodic table. Periodic table. Here in this lecture also we can understood about the basic concept of the periodic table. Basically, there are so many elements. Total 108 in number. Okay, there are total 108 elements in number, and if we want to study them, so first of all we need to arrange them in proper order. Okay, and arranging them in a proper order requires some link, requires some base on which they could be arranged. Got it? So for this we have periodic table. Periodic table in a general term, you can say periodic table in a general term is basically the arrangement of elements. Okay, and the first periodic table was introduced by Mendeleev. On the basis of atomic mass. Got it? So basically Mendeleev said if we arrange elements on basis of increasing atomic mass, then we will have efficient arrangement. Okay, so basically Mendeleev said if we arrange all the elements on the basis of increasing atomic mass, then we will have a efficient arrangement. Got it? But his periodic table was failed, and why? We will have a discussion over it in our upcoming lectures. Till then, just remember, he said we should arrange the elements on the basis of increasing atomic mass. It was a Mendeleev's periodic table. Thereafter, another person whose name was Mosley, he gave modern periodic table. Everything was same, but only instead of atomic mass, it has atomic number. Mangley said, if we arrange the elements on the basis of increasing atomic number, then we will able to arrange them in an efficient way. Okay, we will discuss these things in our upcoming lectures. So in this lecture, we will finish about the basics of the atoms. Okay, in our next lecture, we will have a discussion over chemical combination. Till then, thank you.